This is a video about modeling trig functions using technology, and basically this is accompanies the earlier video about using technology to model trig functions, i.e. Desmos and Excel. So this is kind of like a second video for that. Here we've got an example, and we've got the tidal creek. Okay, so you know those creeks, they go up and down with the tide. They're often not very far from the sea, and this creek goes up and down, and it's got various times there and various depths. Now the time, just to let you know, that's 1st of January of a given year. It's the time in hours, and after basically the crack of New Year's, right? So a midnight, the start of the year. So that's just in order to make it really simple. We need a starting point, and we need decimal time. So I've converted the minute part by dividing by 60. The minutes part dividing by 60 will give a decimal hours. So it'll be something hours, and then the decimal, 2 digits, the decimal part. Okay, so it'll be something point something something hours. Alright, we need to be in decimal form, obviously, because calendar measurement is very awkward with its 60s and its 24s and its 7s, and you know. What we do is need to put this in Desmos, and we can do that by grabbing, don't grab the header, but grab the data, Control C or copy, and then have Desmos open. We can see that it is there. If you haven't got yourself a Desmos account, I would recommend it. That way you can save all your files, but even if you don't have an account, you can just use a Desmos graphing calculator and it'll still function without saving. And as you might have seen before, we simply click into an empty square and then Control V, paste, and it's very clever. It knows that it's a table. So it's if you used Excel. And okay, we seem to have what looks like a hornet's nest, or basically a swarm of insects. So we're like, oh, is that a function? Well, one way we can do that is by looking at regression, and we're going to use trig regression, a bit like we did in the last video. So trig regression is what we're going to use, and basically we can enter in, I'm going to see if sine is suitable. Okay, you could do the same thing with cosine, but we're looking at trigonometry in this video here. So we go y, or in fact, no, I'm not going to go y. I've just remembered that we're talking about, you can, with Desmos, you can add titles and stuff onto your graphs in the spanner section there. So that might be off screen slightly, but there's a little wrench which is your settings, and you can fiddle around for all that in your own time. But basically we've got here D, so you can see where the cursor is D versus T, and that's what we've got there. So I might change that, so you can keep it as X1, Y1, or it might be better if we go call it T versus D. Now you've got to be consistent and stick with those if that's what you're doing, whatever your variables are called. So D will equal, no it won't, sorry, D tilde, so that, remember, that's next to the 1 shift on your keyboard. That means we're going to use regression, and A times, which is an asterisk, sine, open brackets, B, open brackets, X plus C, close brackets, and close brackets again, and plus D. Oh, silly me, habits, that should be a T, I'm sorry, because our variable is T. Apologies, just a habit. Okay, I've just worked out that, don't know why, but at the moment Desmos doesn't like those particular letters D and T. Maybe they're reserved for something else. So I was a bit unlucky there, so what I've done is actually change those back to x1, y1. So x1 is along the x-axis and y is along the vertical y-axis. Okay, so I've put them back down there. Make sure you use those, and you get some values there. Now, if you get something like that or a dense graph, you might want to see if it works better if you switch it over to degrees. Okay, you've got a choice between modeling in degrees or radians, and you can choose. I've just switched it to degrees, and it makes a much better model. And you've got your formulas there. Sorry, your parameters for your formula. So what you can do is use that as your function. So we've got, I've just entered it in there. I've just rounded it to 2 or 3 decimal places there. Don't round too much, but you don't have to use all 5 or 6 decimal places there. It's quite a lot. So maybe 2 or 3 decimal places is good. And that's basically, that will give you your graph there once you've entered it in, and you can use that to make predictions. Now let's zoom in there. We can zoom in and have a closer look. And you've got your time since midnight along the bottom. That's in hours, and then you've got your depth up the side there. And you can do various things there, because basically we've got a good estimate for as an equation due to regression. It gives us a good starting point. So that regression process gives us a starting point to have a reasonable, that's a reasonable estimate of a formula or a function that suits the data. You might be able to improve on it, but so see how it's not perfect. Okay, the points don't sit on there, but they're not too bad. So you can talk about the reasonableness, and as I've mentioned in a previous video, if that r squared is close to 1, you've got a good correlation, and 0.95 is reasonably good. R squared is called the coefficient of determination. What if we had to find an estimate for the depth of the water on the 10th of January? Remember, this starts on the 1st, sorry, January, not J, January, and basically at 12 noon. So we need to work out how many hours that is from midnight on 1st of January. That's basically 10.5 days, so that's 240 is 10 days in hours, and half a day is another 12, so that's 252 hours. So basically, there's 2 ways you need to be able to do this. You can verify with the technology, but you should do it by hand to solve it using proper analytical calculations. So we scroll across and we look for 252. Well, there's 250. May need to zoom in a bit. 250. Now each of these are 2, 4, 6, 8. So 252 is there. So yeah, 252. So 1.11 meters. So that's prediction. Now to do that analytically, you would use substitution. Now that can be, we can get a value for that by substituting into the equation, and basically let's do that. So I'll get my pen happening here, and we've got the depth. We've had to use y because Desmos didn't like it, but you could revert back to d if you want to. It's 0.835, remember we're in degrees mode too, by the way, times sine negative 28.952 times, now x is basically along the x-axis, and that's time, remember. So the time we said was 252 hours, so we've got 252 plus 2.32 plus 1.352. So let's get the calculator. So I just grab my calculator, and I've got 1.11, because it's actually said 1.10888, and that's extremely close to what the graph said. So and you notice I didn't have it on exactly 252. So you need to use by hand methods, but you can verify with the technology. So that's an example of making a prediction in the future using your equation, and that one there gave us a depth of 1.11 meters on the 10th of January, and that's at 12 noon, and you could check that if possible, if the data exists, against the tide times. You'd probably only be finding high and low tides, I suppose, because that's the main ones they